Good morning, boys and girls, and welcome back. Today we're going to be talking about integration by substitution. All right? Integration by substitution is an integration method we have. As we move through this semester, we're going to start picking up new and exciting integration methods. But this is an integration method we have that you'll see it mainly undoes the chain rule. That's kind of what its purpose is. So let me show you a problem that we would use integration by substitution on. Okay, here is an example of when we would use integration by substitution. Okay, notice you will have things that are kind of multiplied by each other. Again, because we're undoing the chain rule, right? If we kind of looked at this as a derivative, you would say, hey, the derivative of this inside part here is 2x. That's where that's coming from. Okay, we're undoing that chain rule right there. Now, you might also be saying, hey, if I were going to integrate this, I would just multiply that 2x by everything, and then I could just integrate, using like the reverse power rule, which you totally could in this case, but that won't always work. So we do want to be able to use the integration by substitution. Okay? Maybe as just a quick review, because it's been a little bit, let's go ahead and let's do this just by multiplying out and doing it normally, and then I'll come back and I'll do it with u sub. U sub is what we call our integration by substitution. All right? Okay, so multiplying out, I get the integral of 2x cubed minus 18x. Integrating that, we end up with 1/2 x to the fourth minus 9x squared plus c. Okay, don't forget again on this problem, when we have an indefinite integral, you always have to have plus c. All right? Double check your work or look at my work here. But that's what, if we integrated normally, that's what this should look like. You're going to see here in a second when we do this using u sub, our answers are going to look different. So again, when you're talking about like a multiple choice answer, depending on the method you use to do the problem, they might be looking for one method versus another. Okay, but technically, you'll see that they are equivalent answers. All right, let's go ahead and do this now using u sub. Okay, when we do integration by substitution, you keep hearing me say this u sub. What we want to do is we want to rewrite this problem in terms of u's. Okay, I'm going to substitute some stuff, u in for some stuff. And that way I can rewrite my integral in terms of u's to make this integral easier to integrate. Okay, and generally what you want your u to be is you want it to be the inside part of the chain rule. All right, so like in this part here, we kind of talked about, hey, like this x squared minus 9 would be the inside part we take the derivative of. So I'm going to come to the side, and that's what I'm going to make my u. I'm going to say u is x squared minus 9. All right? And then what I'm going to do is I need everything in terms of u's, everything. So I'm going to take the derivative of this. The derivative of u is du. There's my differential. Equals 2x. We just took the derivative of x, so 2x dx. And the derivative of 9 is 0, right? It's a constant. So 2x dx is equal to du. And so what we can do now is we can come over here, and the x squared minus 9, that is now just u, and this 2x dx becomes du. But you need to replace all your x's with u's. And this is what we refer to as integration by substitution, or u sub. Okay? But this is something that's way easier to integrate than even what we did before. Hey, the antiderivative of u squared, the antiderivative of u is u squared over 2. Plus c. And then what we can do is we can go ahead and we can go back now that we're all said and done, that we've integrated this nice and easy, and we can plug in for the u. So this is the same thing as x squared minus 9 over 2 u squared plus c. Okay. Now notice again, our answer here looks a little bit different. If I were to double distribute and multiply this out, I'm going to get an answer that looks very, very similar to the one we had before. The only difference is there's going to be some plus number at the end. And if you add that number with the constant, you would still get that. Again, c is just some constant. So the number and the constant is just still some constant. And so they'd end up being the same thing. But depending on a multiple choice test, they might have this answer if they wanted you to do it using u sub. Or they might have the other answer if they wanted us to do it using, sorry, the bell. They'd want us to do it using, if they want us to use power rule. Sorry for the bell there. That was super annoying. All right, anyway, moving on. Let's do another u sub one. By the way, we're going to spend 3 days doing this integration by substitution. u sub, and each day we're going to kind of keep adding more to it, making it a little bit, beefier. So these first, few days are going to be kind of fairly friendly like this, and we're just kind of trying to get used to it. Okay, here. Now we're going to try to take the antiderivative of negative 4x cube root of 1 minus 2x squared. Okay? And so again, this is something, now I can't multiply that through. I mean, this is something we would have been stuck before. We would not have been able to integrate this. So, when we see things multiplying together, again, negative 4x times this thing, this is when you want to be thinking, oh, maybe let me try u sub. All right? So again, we want u to be the thing that is on the inside. So the thing on the inside is the 1 minus 2x squared. All right? I'm going to take the derivative of that. The derivative of u, derivative of 1 is 0 minus 4x dx. And now for today, you should see that, hey, we're going to get things that match up pretty nicely for the most part. Okay? That worked out rather well for us. So now we could go ahead and we could rewrite this as the cube root of u, right? Cube root of u, or u to the 1/3. And then negative 4x dx is du. But you need everything in terms of, again, of u's when we write this. You don't want u's and x's together in the same thing. That is bad stuff right there. But this is the inside there, so u cube root of u, or u to the 1/3. And then all that, all this was all this right here, negative 4x dx. Okay? And we're just doing some direct substitution. Hence integration by substitution. All right, now I'm going to integrate this. So if I add 1, I get 4/3 over 4/3 plus c. Or we could say that this is 3/4. U is 1 minus 2x squared. The 4/3 plus c. And you can see, hey, when we use u sub, our integration actually turns out it's really nice. It's not a bad deal and fairly friendly to do. All right, moving on. Okay, so here we go, another one. Getting a little trickier now, a little bit crazier. All right. Again, this is one I would not be able to multiply out on. I mean, I guess I could, but you'd have to raise this to the 4th power, which is not going to be a pleasant, fun time, and then multiply everything by x squared. This is just way easier to be done with u sub. Okay. So starting again, the inside part, that is our u. So I'm going to say that u is x cubed plus 5. And then I need to take the derivative of this. So the derivative with respect to u equals 3x squared dx. Now here's where we're getting a little bit crazier, a little bit, when I go to substitute in here, integral, I've got my u to the 4th, that part right there, right? But this whole, trying to substitute this part in here, I've got an x squared dx. I've got this piece right here, the x squared dx, but I don't have that 3, okay? So that is causing me a bit of an issue. So what we're going to do to fix that is, because this is just a constant, I guess, is I could go ahead and I could divide both sides by 3. And so I've got du over 3, or you can say that's 1/3 du is equal to x squared dx. And so now I can kind of deal with that, because now over here, really I'm going to plug in for that stuff. I'm plugging my 1/3 du. And now what we would normally do, though, is this 1/3 is just a constant. So now I can pull that out to the very front. So I get 1/3 integral u to the 4th du. And so we can still integrate this using integration by substitution, or u sub. All right. So now integrate that, and I have the 1/3 just hanging out. I get u to the 5th over 5 plus c. Or if I put this stuff together here a little bit, again, really you could distribute this 1/3 to everything. Right? 1/3 times c is still just a constant. So I would say I get u to the 5th over 15 plus c. And then if I plug in now, my u again was x cubed plus 5. So x cubed plus 5 over 15 plus c. I'm not sure I've been writing my answers. You might also see this as 1 over 15 times x cubed plus 5. You know, running out of room, but plus c. Okay, that's another way you could totally see this answer as well. Both these things are the same thing. And you should be able to write your answer in either form. All right, one more quick one, and we are done for today, boys and girls. Okay, last one here. This one looks a little bit different because things aren't multiplying together, although we can always rewrite division as a multiplication problem by just making that a -2 exponent, right, on the bottom here. Make that a -2 and multiply it. But again, I don't know. So when things are multiplying / when you have an inside, that is my indication to use U sub, or integration by substitution, as my integration technique. Okay. So again, we're going to start. The inside part becomes 1 plus x to the 4th. Okay. So then du is 4x cubed dx. All right. And so again, I've got this x cubed dx multiplying by each other. So that's good, right? I don't have that 4. So like we did in the last problem, though, this is about as complicated as we're getting today. I'm going to divide both sides by 4. So du over 4 is x cubed dx. And then so now I have the integral of 1 over u squared du. But that 1/4, again, what I tend to do is I just tend to bring it out in front in the very beginning. Okay, you could put d over 4, but I'm just going to pull that out to the very front. And then so now, I guess I even could have written this as 1/4 integral u to the -2nd du. And now I can integrate 1/4 times u to the -1st, add 1, divide by the new exponent, plus c. And so we get now -1 over 4. This u is going to go to the bottom. So -1 times 1/4 is -1/4. This u has a negative exponent, so it's going to go to the bottom, times 1 plus x to the 4th plus c. All right, and that would be our answer. So there we have it. U sub, day 1. Easy peasy lemon squeezy. Give this a go, and we will talk about it soon. See you later, boys and girls.